Hi guys, today we're going to talk just briefly about the trigonometric identities and where they come from. Eventually you'll have to memorize these, but for right now, like they are given to you and you should reference these throughout the next few sections. So first off, I want to identify or establish that we actually know these identities right here that are called reciprocal identities already. That cosecant is a reciprocal of sine, secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. We then also know tangent and cotangent identities, which state that tangent theta is sine theta over cosine theta. Cotangent theta is cosine over sine, right? So they're reciprocals of each other. Now, these 5 identities at the top here do a really good job of making your, later when we look at trig identities, it changes everything to sines and cosines, which are really helpful if we wanted to simplify things. The new one that I want to talk about is the Pythagorean identity. And this one comes from the Pythagorean identity, which is like a squared plus b squared, Pythagorean theorem, sorry, equals c squared, right? Where c is your radius. Well, on a unit circle, we know that our radius is 1. And so that's where this comes from. We also know on a unit circle that we can use x's and y's, but we can also use sine and cosine. And hopefully you remember that sine squared is the same as y squared, and cosine squared is the same as x squared equals to 1. Right? So really you can say that like y squared plus cosine squared equals to 1. How we get this identity is very similar to this, right? So this is just another form of the same thing. And the really cool thing is if you take this first function and you divide everything by cosine squared theta, you get this. So let me show you, and I'm going to pull out like a separate piece of paper to write on. Okay, so really what we're going to do is take this and we're going to divide, and divide by cosine squared theta, cosine squared theta, and cosine squared theta. Now, cosine squared theta is the same, I forgot to establish this, is the same as cosine theta squared. But the reason we don't write it this way is because it requires extra parentheses. So we're really lazy. And then if you don't do parentheses, this squared means you have to square your theta, right? So these are not the same. So we want to just write it as cosine squared theta, so it's a little bit easier. Okay, so let's simplify. These two become 1. 1 over cosine is secant squared theta. And then sine over cosine is tangent, but since there's 2 of each, it's going to be tangent squared theta. And you see how this is the same as this. Okay? This one is going to be the same, but we're going to take this first one and we're going to divide everything by sine squared theta. And we get this. So if you wanted to try that for yourself just to prove that it works, that's where this one comes from. Okay? The next thing we can talk about is function identities, which are actually just, sorry about that. Co-function identities recognize that sine graphs and cosine graphs are very closely related, right? If we have a phase shift of pi over 2, then our sine and cosine graphs are exactly the same. And it just depends on how you wanted to shift them. So sine of pi over 2 minus theta can become cosine. And we can have cosine of pi over 2 minus theta going to sine. You guys have also talked to me about this one before. And this one is where we recognize that tangent and cotangent are actually like the same graph. They're just shifted as well. Okay? So this negative angle identities is once again something that we've already done before, or like we've worked with this, and this just has to do with our sines. So if we have a negative angle, let's draw this here. I'm not going to draw the circle, but a negative angle means we go this way, right? So we have a negative theta here. Okay. Well, if I take sine, which is y, of my negative theta, that could be, say, like, I don't know, let's pretend it's negative 1/2. Okay. If I take the positive theta and go in the same direction up, do you guys see how it's the same y value, right? But one of them is negative and one is positive. So if we multiply the positive sign of a positive theta by negative, these two are actually exactly the same. So we'd have negative 1/2 and negative 1/2. Okay. The same goes for tangent. Okay, so a negative theta, like a negative angle, means that your tangent is just going to be the negative times the tangent of a positive one. Cosine's a little different. So this one I want to show you guys because cosine is your x value. So I'm going to draw the same thing. Okay. But now we want to talk about x. So this is x, or cosine. Well, do you guys see how it's the same for the negative and positive theta? Like the x values are the same, so the cosine of this angle, positive or negative, is the same because they're both x. So this negative cosine of a negative angle is the same as a cosine of a positive angle because they share the same x values here. Okay, so just know that this is not a typo. There's no negative for cosine. So I'm going to move on to notes in a different video. So this is just in case you needed to clarify where these trig identities come from.